In this lesson, we are going to practice all of the transformations that we have learned thus far. So you know how to do everything. We know how to transform a function that has a value for a, k, d, and c. So just as a quick review, our value for a affects the vertical stretch, compression, or reflection. So that's a reflection in the x-axis. Our value for k affects the horizontal stretch and compression. So our x values as well as reflection in the y-axis. Our d is a horizontal shift, either left or right, and our c is going to create a vertical shift, either up or down. So taking a look at the first example, we have a random function and they've named the function f at x. So this is not one of our parent function. We've created a new one, and what we're going to do is we're going to transform f at x based on these transformations. So if you notice, the f comes from this f here. So we are going to apply these 4 transformations to the function f, and we're going to do it again here. So the first thing that we will need is we will need the original points of this function. So that's going to be, I'm going to take, let me do it in blue so that you can see. I'm going to take this point down here, this one, and this one. So listing from left to right, our major points are -6 and 0, -5 and 3, -1 and 1, 4 and 3, and 6 and 3. And again, these aren't the only points you can use, but these are the ones that are clearly marked. So we've got all of these sort of vertices here. So we've got 5 points, and these are the ones that we're going to transform. So we're not going to list the transformations because the question didn't ask us for it. We're just going to transform these points. So I'm going to make a t-table to keep track of what we have to do to our x-coordinate and what do we have to do to our y-coordinate. So we've got x and y. Start off with x and y over here. Okay, so let's quickly label this. So this is our a value here. We don't actually know our d value because we need to factor this -1 out before we actually see the true value of d. So I'm just going to factor it up on the top here. So we've got 3 inside the function. We have factor out that -1, and we're left with x minus 4 plus 1. And now we have a better idea of what's going on here. So actually it looked like it was a shift to the left, but actually it's a shift to the right. Okay, so we have our a value. So it's going to be a vertical stretch. Vertical, it's affecting the y value, so we're going to multiply all the y values by 3. Now let's look at this -1. This -1 is going to affect the x values. All the x values are going to get divided by -1. Okay, next we have this -4. We know that's a shift to the right, and so we're going to add 4 to all the x values. And then last but not least, this +1 is our c value. It indicates that there's going to be a vertical shift up 1, so we're going to take the y values and add 1 to it. So now that we've got a summary of what we're going to do the x and y coordinates, we're going to rewrite these original points as the transform points. So instead of writing it twice, since we can visualize these guys because these ones are right here, I'm going to apply all of these transformations to the x coordinate, and then we're going to apply these transformations to the y coordinate. So I'm just going to list out the new points here. So we have 1, 2, 3, 4, 5. So now let's go ahead and we're going to take this x value, we're going to divide by -1 plus 4. So -6 divided by -1 is 6, plus 4 is 10. And we'll do the next one. -5 divided by -1 plus 4 is 9. And we're going to continue with the rest of the x coordinates. Now that we have the x coordinates complete, let's go ahead and we'll start working on the y coordinates. So I'm going to take this 0, multiply it by 3, and add 1. So 0 times 3 is 0, plus 1 is 1. Now before we continue with the next one, I realize there's a little tiny mistake right here. So this point here is actually the point -1, -1. So make sure that you add a negative. Okay, there we go. Okay, so we've just added a negative here. We're going to continue. So now we're going to take our 3, we're going to multiply it by 3, which is 9, and add 1, and we're going to get 10. So now we're going to continue this for all of our y values, and you should end up with these points here. So I'm going to quickly graph them and connect them and make sure that the graph looks like it's been transformed this way. So now that we've got those points graphed, let's connect them. So you guys can use a ruler when you connect them. I cannot. Okay, my drawing was terrible. Let me retry. Okay, so here we've got our completed graph. It's definitely been vertically stretched. It's been reflected in the y-axis. It's been shifted to the right 4 and up 1. So now let's try this guy over here. So what I'm going to do is I'm going to leave you to create your own t-table, and then we'll come back together. Don't forget, before you do that, we got to factor this. So let's zoom in on this very quickly. So in order to find the true value of d, so what kind of horizontal shift there is, we need to make sure that we isolate for x. So let's factor out that 1/2. So we're going to have y is equal to negative f. Factor out that 1/2, and we'll be left with x plus 2, all bracket, and minus 4. So now go ahead and make your t-chart and put in what you're going to do to the x-coordinate and what you're going to do to the y-coordinate, and come back and check in the video. Okay, so if you're done, this is what we're going to be applying to our coordinates. So that negative is going to be a reflection, and the x-axis is going to get multiplied by y. That's our a value. After we factored out our k value, we're going to divide it by all the x-coordinates, or we're going to divide the x-coordinates by that k value. We've got a shift to the left 2, so we're taking our x-coordinates and subtracting 2, and finally our entire function, all of our y values are going to be shifted down 4, and that's why we're subtracting 4. So now go ahead and apply these transformations to the original points and check back. Okay, so these should be your final points here. We've taken all of the original x-coordinates, put them through these transformations. We've taken all these y-coordinates, put them through these transformations. Here's our final points. So now let's quickly graph it on the grid over here and connect the dots. Now that we have our points graphed, let's connect them. And you'll get a graph that should look something like this. So we see that this part of the graph is over here. This part of the graph is over here, and then we have our pointy part, which is over here. So if we take a look at the transformations, there should be a reflection in the y-axis, and in the x-axis, and that has happened. So this guy's down over here now. There should be a horizontal stretch, and that's clearly happened. We can see that these x values have gone from this range from this domain to a much wider domain. Our x's should have been shifted to the left too. That's also happened. It's generally shifted to the left and moved down 4, and this has also happened. Now we're ready to get started on example 2. This question is a little bit different because instead of being given an equation, we're given clues to create an equation. So we're given the parent function and the transformations that we're going to apply to that parent function. So if we just sort of decode this with letters, it should help us. So we know that the parent function is the square root of x. I'm just going to circle this guy. Okay, so one hint that we're given, it's stretched vertically by a factor of 5. So we know that that's going to be our a value. Vertically stretched is our a value. Reflected in the x-axis. Reflection at x-axis it means that all the y's are changing. Therefore, it's also our a value. That means our a value must be negative. It's translated 4 units to the left. So that's a horizontal translation. So that's our d value. And 2 units upward, that is going to be a vertical translation. So that is going to be our c value. So let's take this information and put it into an equation. So I'm going to write y equals, we have a square root of x. That's our original parent function. And now let's add in our a, our d, and our c. Taking a look at this, we know our a, if it's vertically stretched by a factor of 5, our a has to be 5. And so we're going to write a 5 in front of the function. Make sure it's outside the function. On top of that, we know a has to be negative because there's a reflection in the x-axis, so we're going to make this -5. Now we know that it's going to be shifted to the left 4, so we're going to put a +4 here inside the function, so it's a horizontal shift. And finally, the function has to be shifted 2 units upwards, so we're going to add 2 here. So at the end, I just like to check by rereading the function and making sure that it matches this. So we have a vertical stretch by a factor of 5, check, and a reflection in the x-axis, another check. Now we have a shift to the left 4, that's what we were given, and a shift up 2. So now try this next one on your own and check back in the video if you've gotten the right answer. So if you're checking back in now, here's the equation that we're left with. So let's go back and take a look to make sure that we actually have it right. So something to note is to make sure that your k value is within the function itself. So the cubed should be applied to that 1/3. So if that -1/3 or whatever it is that you have as your k value is outside, then it's actually a, and it's going to affect the y coordinate, not the x coordinate. So let's go through this one by one. So we know that the parent graph is the cubic function, which is why we have this cube here. So it's compressed vertically by a factor of 1/2. So compressed vertically, that means that this is our a value. So this is why our a value is 1/2. Then it's stretched horizontally by a factor of 3. So stretched means that whatever k value, the k value is the absolute value of it must be less than 1. So we know that if what we're multiplying all the x's by is 3, the original k value must have been 1 over whatever that is, and that's 1 over 3. Then we know that it's reflected in the y-axis. That's also part of our k value, because if it's a reflection in the y-axis, that means all of the x values have changed, and so we are going to make that k value negative. Next, we have a horizontal translation to the right, so we know that that's going to affect our x. Make sure that there are brackets around the x minus 5, because if we were missing the brackets, then it wouldn't actually be a transformation of 5. We'd have to factor out our k value first to be able to figure out the transformation. And last, we have a shift downwards of 4, and this is why we have a -4 on the outside. So now we're going to try 2 last examples to make sure that you know exactly what you're doing. If you're feeling confident with this and you prefer to try them on your own and just skip forward in the video, please feel free to do that. Just as a reminder before you go, remember that we need to make sure that our x value, the coefficient of x, has to be 1. So we're going to have to factor this guy out before we know our true horizontal shift. Another note is that we've written this in sort of a different notation. You can see this f that stands for the function. So we've been given a function to apply it to. So if you're confused by that, you can rewrite it so that we don't have f for function, but we can actually apply it to the absolute value function. So if I were to rewrite this with the absolute value function, it would look something like this. It would look like -3. And then this is f, that's where the function begins. So now we're going to put the absolute value signs, and we have -0.5x minus 1.5, and then we have a +2 sitting outside of it. So I am applying these transformations to this function. I also have to factor this guy, so I'm going to try to squeeze it in right underneath. So this guy is going to factor to, we're going to leave the -3 alone, and we're going to factor out this -0.5 so that the coefficient of x is 1, bracket x, and then we're going to be left with a +3, and then we have +2. So we can quickly expand this in our head just to triple check. -0.5 times x is going to be -0.5x, and -0.5 times 3 is going to be -1.5. And now we're ready with our transformations. So just to get some more practice with naming, even though it doesn't ask, I'm going to quickly name these transformations. You can go ahead and check your own understanding as we go. So we have a negative value, or our a value is negative, so that means we are going to have a reflection in the x-axis. The absolute value of a is 3, and that's greater than 1, so there's going to be a vertical stretch. And I'm going to say by a factor of 3. I'm just going to use a short form there. AFO by a factor of 3. Okay, let's look at the next guy. Okay, our k value is also negative, so we're going to have a reflection in the y-axis as well. Reflection in the y-axis. Okay, the absolute value of k is 0.5, and that's less than 1, so we are going to have a horizontal stretch by a factor of 1 over 0.5, which is going to be 2. So we're either going to multiply all the x values by 2 or divide them by 0.5. That's essentially saying the same thing. So now we got this guy. We have a 3 being added to our x coordinate. We really know it's being subtracted. So we have a horizontal shift left 3. And we have a vertical shift up 2. Now let's quickly make our t-table to keep track of what we're going to do to our x-coordinate and our y-coordinate. Okay, so one by one we have our a value, and we know we're going to multiply that by our y. That's going to take care of our reflection and the vertical stretch. Next we have our k value. So our k value is going to get divided, or the x value is going to get divided by our k value, so divided by negative 0.5. And that's going to take into account a reflection, the y-axis, and a horizontal stretch. And now we've got to shift the entire function to the left 3, so we are going to subtract 3. And our y values are going to be shifted up 2, so we're going to add 2. So now that we have our key, we're going to write out the original points of the parent function, and our parent function is f of x is the absolute value of x. So let's write out some points. Let's do negative 2, 2. You can pick whatever point you like. Negative 1, 1, 0, 0, 1, 1, and 2, 2. 5 is just fine. And we are going to transform these guys using the sort of key that we've created over here. So every x value is going to be divided by negative 0.5 and subtracted by 3. So apply these transformations to the coordinates, pause the video, and then come back when you're done. So here are our transform points, and now we're just left to graph them. So here are our graphed points. Let's zoom in a bit, and we're going to connect them really quickly. Okay, make sure that you extend it beyond those points, because we know this transform graph is going to continue on. And here we have the transformed graph of the absolute value function. So if we're just checking over, we want to make sure there was a reflection in the x-axis. That did end up happening. There was a vertical stretch by a factor of 3. This is skinnier than the original graph. There was a reflection in the y-axis. The graph is horizontally stretched, shifted to the left 3 and up 2, which is what we have. Let's finish up with our domain and range. So the domain of this absolute value function is that x can take on any real number, and our range, y is an element of R, such that it has to be less than 2. So y has to be less than or equal to 2. Now we're going to take a look at our last example. So in this example, again, we have these transformations being applied to f, this function, and the function is defined as the square root function. So we're going to apply all of these transformations to the square root function. So if you need to write it out so that you see the square root, you can. So it would be looking like y equals 1.5. Instead of f, we have actually the function. And underneath that function is negative 2x plus 4. and then we're going to subtract everything by 3. So don't forget, before we go ahead and transform this, we don't know the true value of d until we make sure that the coefficient of x is 1. So we got to factor this guy out. We'll be left with y equals, or f at x equals 1.5 square root of, that negative 2 stays inside the square root, and we're left with x minus 2, and then minus 3. So we won't name them this time. If you want to name them, absolutely go ahead. We're going to make our t-table, keep track of what we're doing to x and what we're doing to y. Let's work on these one by one. So remember that this is our a value, our k value, our d, and our c. So go ahead and make your key and then come back and check in on your answer. Okay, so we have our a value being multiplied by y. We have our k value being divided by x. This is a shift to the right 2, so we're adding 2, and a shift down 3, so we're subtracting 3 from our y. Now we're ready to transform our points. So we're going to start with our parent function points, and this time our parent function is the square root of x. So I'm going to quickly throw out those points. So we have 0, 0, 1, 1, 4, 2, and 9, 3, and that's good enough for this function. And now we are going to transform these guys using the key that we have to the left. So we're going to take all our x values, divide them by 2, and then add 2, and our y values, we're going to multiply them by 1.5, and then subtract 3. So now that you've gotten your points, this is what you should have. We have the point 2, negative 3, 1.5, negative 1.5, 0, 0, and negative 2.5, 1.5. So let's graph them now. So here are our points all graphed. We're going to connect them quickly so that it looks like a square root function. So this looks something like that. Okay, we're just going to do a quick check. First of all, these points are aligned in a square root function, so we know that that's a good sign. Also, just take a look at our transformations here. There should have been a vertical stretch, so our y value should be stretched, and that looks like that happened. There should have been a reflection in the y-axis. Remember, the square root function normally looks like this, so there's definitely been a reflection in the y-axis. The x values should have shrunk, and that looks like it should be the case. Normally, it sort of stretched out more, the x values. Then it should have been shifted over to the right 2, and that happened, and down 3, that also happened. So now we're just left with filling in the domain and range. So the domain of this function is x is element of r, but x has to be less than 2. X has to be less than or equal to 2. Now let's take a look at our range. So y is an element of r, but y has to be greater than negative 3. So we have y is an element of r such that y has to be greater than or equal to negative 3. And we're done.